Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Information Week webinar, 5 Steps to Solving Modern Scalability Problems, sponsored by Dell and broadcast by Informa. I'm Peggy Bresnick-Kember, and I'm with Information Week. I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. You may also download a copy of the slides via the Resources widget. Toward the end of our webinar, we'll ask you to complete our survey. It's found on the right-hand side of your screen. Please take a moment to fill this out before leaving us today, as your feedback provides us with valuable information on how we can improve future events. And finally, if you experience any technical problems, please click the Help widget found at the bottom of your screen, or simply type your issue into the Q&A area, and we'll be glad to offer one-on-one assistance. Now on to today's presentation, 5 Steps to Solving Modern Scalability Problems. Discussing today's topic is Patrick Callahan, Partner, CTO at DataStax. Patrick is the Partner CTO at DataStax. He works with enterprises and partners to implement and support large-scale mission-critical applications across hybrid cloud environments. Prior to his current position, Patrick held roles in the banking and finance sector as a consultant covering real-time distributed applications. Also joining us today is Phil Hummel, data scientist at Dell Technologies. Phil's career started in the energy sector, where he researched market adoption of energy-efficient technologies in residential, commercial, and industrial sectors, while working in government, private, and nonprofit consulting and R&D roles. He left the energy sector in 2000 to work at Microsoft in pre-sales and consulting for SQL Server with a specialization in analysis services and data mining. Phil joined Dell Technologies in 2010 as a pre-sales specialist for data platforms, big data, and analytics. His current position is Distinguished Member Technical Staff working on machine learning and AI at Dell Technologies. Welcome, gentlemen. Over to you.
Thank you very much. I hope you can all hear me. Thank you all for joining us today. This is Patrick Callahan. I'm coming from the east coast of Ireland, so you might have picked up a little accent there. So yes, we're going to just talk about, there's lots of steps that we're going to talk about today, 5 steps to solving these modern scalability problems, but it all starts with the data itself. So as you can imagine, we're creating huge amounts of data. As you can see here, 59 zettabytes of data in 2020, according to IDC. Now that some of that may account for, Netflix and Spotify for the year that's been in it. But a lot of that information is just, maybe it's data from IoT devices, smart devices, but as you can see, it's actually growing more exponentially than we can even imagine now. Like I can't actually fathom what 59 zettabytes is. But by the time we get to 2025, we're going to be at 3 times that, 175 zettabytes. So IT leaders across every industry are still struggling with this problem of increasing data volumes. Like, how are we going to manage this going forward? And all this growth puts a huge amount of pressure on IT systems. And we think about databases as the storage or the memory of what we do in our business and our interactions with the world. So how do we think about how we're going to scale this for the future? And sometimes we think about, just adding hardware. And, that's one way of solving a problem, but it's not the best way, right? So then we think about scaling out the system in terms of a horizontal scale, but that sometimes increases the processing time. We think about things like scatter requests or sharding, large databases. And again, they come with their advantages and disadvantages. But what we really want to be able to do is to create a database that accounts for our needs. So if the data comes in faster, more of it, the database will scale, to accommodate those throughput increases and also those storage increases. So if we think about what we do, a lot of the time, people have started with relational databases. And if you think back to 10, 15 years ago, and the explosion of companies like Facebook and Netflix and Apple and so on and so forth, something had to give. And the give was distributed databases. And like NoSQL databases, like Apache Cassandra, these were created out of a need for more data and more throughput than relational databases could cope with. And really what it allowed you to do was to scale a system based on both throughput and storage. You want more throughput, you add more nodes. You want more storage, you add more nodes. Very much like a web server. If I have 10 web servers, I could accommodate 1 million writes per second. If I need 1 million more, I just add more servers. So again, very simple way of thinking about throughput and storage, but that's how we came to distributed databases. That in turn created an idea of new types of databases, new types of expertise, requiring more staff, more technical resources in that stage. But there is other options to, other architectural models for scalability, and we'll talk a little bit about them today. So one thing that I think is important, just when we think about scalability and distributed databases, what we want to do is to have a database that scales with the application throughput that we have. So if we think about companies like Spotify or Netflix, we have to think about how can a company build a foundation, a distributed database that allows them to scale to their business needs. And another example is like people choosing single databases today, the big appliances, find it very difficult to horizontally scale. There is options, of course, to vertically scale, adding hardware and more processing power. But there is always a ceiling to that strategy. And I remember talking to someone about it in the sense of Uber. If you think about the way we used to solve problems with databases, it's like Uber having one car that's very successful. And then they decide they need to increase the throughput and storage of their capability. So what they do is they get a minivan or an SUV. And then they hit, they reach, they exceed the limitations of that, and they get, a coach or a small bus. And really what the problem is that every time you run up against these limitations, you have to change a huge amount of your infrastructure, or you have additional costs or retraining or whatever it may be. But the simple answer to Uber is instead of getting a bigger car, you get more cars. And that's what a distributed data model is. So when we have, like Cassandra, we have databases that are split across maybe tens or hundreds of nodes, and they can all make up the one database or the one cluster. And this is really important because then if we want to scale the database, just like we do when we're scaling applications, we can just add nodes or add machines to be able to extend the capabilities of the platform. So that's really where we come to migrating to this distributed data model allows for that elasticity, right? I can move my storage requirements and my throughput to accommodate what's happening to my systems as they're needed. So NoSQL databases like Cassandra in particular have this distributed data model which in a sense, we've seen distributed databases before, and we've seen people shard databases. But a distributed data model is kind of different. And if you come from a background of, program management or project management, you might think about a distributed data model is like an agile team, where everybody knows everything that everyone else is doing. And you compare that to the kind of project manager where there's one person involved and he leads a team of 5 people and he's the go-through, right? He knows what people are doing, but no one else underneath him does. And if you need to get some information, you have to go through the project manager. That's a bottleneck. That's a problem. But in an agile team, you can ask anyone in the team, what is this piece of data? Or can I have this piece of information? And if they don't have it, they will be able to direct you to someone who does. And that's the way a distributed data model works. All the nodes or machines work together as a group to be able to provide information to clients. Phil, did you want to just add something here?
Yeah, so, this idea of the relational database systems, SQL, Oracle, DB2, MySQL, they've all made innovations to emulate something that looks like distributed. So if you're doing replication out to read-only copies and you're trying to solve your scalability challenges that way, this might be a really interesting alternative for you.
Yes, thanks, Phil. So people have always sharded databases, but really what that does is it really just gives a read capability. But what we want to be able to do is write capability as well. And distributed databases like Cassandra are perfect for that. Another thing about NoSQL databases is they have different models in terms of how you interact and save your data. So a relational way is sometimes quite wasteful. Sometimes it's, we talk about third normal form and similar. They're set in a very strict way that there's no leeway to be flexible around their data model, their schema, and the column structure. And, when you think about, if you go back to, 10, 15 years, and you think about varchars and how data used to be, what's the word? You have a varchar of 500 characters, but you only use 2, right? So then you've wasted 480 or 98 characters, and this is over all databases that you use, this kind of wastage comes up. But distributed databases are different, and they're different by the way they use their models as well. The schema and the actual data itself can be detached. So the schema is set in a way that you can evolve the schema without touching the underlying database or the underlying data. And that means that you can change the database very, very quickly. For example, with Cassandra, you can add columns, and it only takes a split second because you're changing the metadata rather than the data structures. And these can be really quite useful when you're doing quick deployments, quick changes to applications. And there's different types of structures. So you have things like key value, which can be really useful for authentication or session management. You have column family, which is a bit more towards a time series based, so eventing and streaming. You have graph models, which obviously take in the richness of relationships between entities and puts that forward as the querying pattern. And then you have document stores, obviously very popular with the way JSON works and similar technologies. So you get a breadth of the kind of capabilities that you're exposed to when you move to a NoSQL database. So another thing that kind of goes hand in hand with NoSQL databases is the microservices trend we've seen over the last 10, 15 years, moving from a monolith, very slow kind of waterfall approach to creating software and services to a much faster, rapid, continuous deployment model of creating applications, changing, updating, and be able to deploy them as a single microservices. So one service that does one thing very, very well. And that sits well with a type of polyglot approach to data persistence. So if I have an application or a service that's specifically well suited to a document store, well, then I'll use a document store for that service. But if I have another service that's particularly well suited to time series or customer journey activities, then I will use a database that's more suited towards that. So the way we work in this environment of microservices is more towards scalability and speed. But what that does is it also comes towards a way of managing those microservices through what we think of now as containers, or used to be VMs, but we work now with more Docker containers, and then we use orchestration tools like Kubernetes. So when you think about that, then you want to be able to think, well, what is the database I'm going to choose to use for each microservice? And unfortunately, some of this can cause, database sprawl. You have lots of different databases for different microservices, and then how do you do, things around cross microservice transactions? These can all be quite difficult. But microservices are the way forward. Kubernetes has won the orchestration war. And when you think about how distributed systems are going to work with distributed applications, they really fit hand in hand. And in a way, this is where we see, all the private clouds going: distributed systems, distributed data storage. Was there a question there?
Well, I was just going to say, as part of that developer story, another thing that you want to think about is what kind of clients when you choose technology, what kind of clients can you support? And I think as we move on here, you'll see that there's a wide variety of clients that all can support these NoSQL databases. Yes,
absolutely. And, one of the things, we talk about traditional deployments, and then we talk about the virtualized deployment. So, of course, VMs are pretty ubiquitous in all enterprises, and containers sit within VMs, or they can sit externally as well. And Kubernetes really is then the real tool that we see making this all work seamlessly. It automates a lot of the processes, it does balancing, self-healing, and just reduces the whole management burden of this. And this really plays into DevOps and how Agile teams appreciate the fact that Kubernetes is making it easy to move applications from development to testing to production servers, and it's speeding up the whole development process. And we like to think from DataStax point of view that simplicity of deployment should go hand in hand with the data strategy as well, right? So moving data from a dev to a test to a production should be as easy as it should be as the application. So when you think about Kubernetes for applications, you can kind of think Cassandra and Kubernetes at the same time. And then you have also, the Dell infrastructure that's going to provide the horizontal scaling and optimizing, a lot of the software and hardware integration there as well. So we're also doing some work with persistent memory, which is a really interesting part of what we're doing with Cassandra. And that's where the data model can be split and some of it's stored in DRAM versus the persistent part, which is stored on disk. So there's lots of things we're doing under the covers in Cassandra and DataStax to help that Intel and Dell story as a whole. So one thing that's really important for developers now, that when we think about, you think of ISVs and people building products and services, it's a difficult time to be building applications and services from the point of view of there's so many deployment options. Like, where is your service? Where is your product? Where is your applications going to live? And this really comes down to how do you approach the new world we live in from a development point of view. And we simply call this cloud native development. So how do you be a cloud native developer? And one of the main things is embracing distributed technology. So embracing distributed databases, distributed data models, distributed orchestration tools like containers and Kubernetes. So in a nutshell, a cloud native application is designed from the ground up to take advantage of the benefits of cloud computing. So in practice, this often means deploying a NoSQL database, developing applications with microservices architecture, and then using Kubernetes or other automation tools to be able to manage that environment. And this obviously makes things hugely beneficial when it comes to deploying on other other infrastructure as well, whether it's hybrid or multi-cloud or so on. But it gives people the flexibility of writing the application once, having the same database that's going to be portable over any infrastructure or integrated into any ecosystem. So flexibility and ease is going to be a huge importance in that way. So.
The ability to have a development environment that is a database in a single container and your apps in containers that you can easily deploy. But then when you're ready to take that to a production level, it's all the same technology. It's scaled out everywhere at every layer in the stack.
Yeah, absolutely, Phil. I mean, one of the things that Kubernetes and Docker have done they've made it very lightweight portability of applications. When we think about how we want to deploy or move applications from one infrastructure to another, Docker has made this completely simple. Now, from a DataStax and Cassandra point of view, we want to make sure that moving the data to those places is just as easy. If you have an application that you're moving from one place to another, if you don't move the data that it uses, then all you've done is create a gap. And what we want to make sure is that when you move application, you move the data with it. And that data becomes then an easy, simple module that allows you to have that portability, cloud native, multi-cloud, hybrid cloud, whatever it takes. So just kind of summing up where we are, we think about how to future-proof your environment. And looking back, we work with a lot of retail firms, we work with a lot of IT firms, and if you look back 10 years to the people who built on the right technology at the time, and I mean this from the point of view of they built for the future. These are the companies like the Netflix, Spotify. In retail, you look at Home Depot or Lowe's. They built the right technology that allowed them to do the things they're doing in the future, right? Exponential growth, huge amounts of services, huge amounts of customer insight. Like that really is the golden, the golden trophy at the moment. How well do you know your customers? And the only way to know your customers is to collect as much data as you can and be able to understand what that data means. So that means changing data into insights. But those technology choices have to be made up front. And, it cannot just be about a database anymore. If we think about today trying to solve problems of modernization or migration to cloud native technologies, we have to choose databases that are going to allow us to use what's next. And what's next is automation. What's next is AI, machine learning. I was recently on an Accelerate, what's the word I'm looking for? Conference. And they talked about the change from business intelligence, which is kind of batch analytics, to real-time analytics, right? So this is more about the streaming, monitoring, alerting, being proactive about what you do with your data. And this is really where Cassandra has played in the last 5-10 years, right? Real-time value of data. Now we're moving to a different phase. Now we're moving to what GCP call continuous intelligence. And this is where we get into real-time AI. And we can talk about IoT, we can talk about automation, manufacturing, but really what we want to get to is a point where your AI or services or your processes can automatically gain insight into the data that's flowing through it, and then to take action, proactive action without any human interaction at all. And that's really where we're going as a company as well. And working with Dell and Intel, we see great synergy in what we're doing together. But it really is about preparing now for the future. So I'll just tell you very quickly about our company. DataStax is built on Apache Cassandra, and if you don't know, Apache Cassandra is one of the biggest databases in the world, NoSQL databases that is, used by the likes of tech giants like Apple and Facebook and Netflix, but also by some of the biggest logistics firms like FedEx, but also banking systems like Capital One and so on. But what it does is it provides a platform for creating modern cloud-native applications. And this mainly revolves around the database. So having flexible database that's able to scale, that's able to have that elasticity that it can move in and out of the cloud, hybrid cloud, multi-cloud. It deploys on-premise, VMs, containers, and all that. And we work a lot with the Kubernetes community to have a very tight interaction there. What we do as a company, obviously, is we bring that to the enterprise. We bring the open source Apache Cassandra, all the integrations, all the tooling, and all the monitoring and support to that as well. So just a very quick example of what we do. When we think about modernization, there's a journey that most companies are on now, and it's modernizing and it's transforming. And really what that means is, modernizing is just about software and hardware, really. Maybe it kind of comes into culture and processes, people as well. But transforming is changing the identity of a business from one that's focused around maybe people and process to around data. How do we change to become a focus, sharp, focus on the data within the company and make that work for us? And Capital One is just an example of where, taking data from what we consider legacy systems. You can take data from maybe a mainframe where, access to the, transactions within the bank has been difficult, historically. Move it to a place, what we call an enterprise data layer, or operational data store, where the transactions sit outside of the mainframe. And what that allows you to do is to provide a consistent view of all the data within the bank. You can enhance transactions with maybe customer interactions, or you can enhance them with maybe automation or fraud, or lots of different processes. But what you're doing is pretty much freeing your data. And this really comes into a lot of different places where we think about insurance, we think about healthcare, and all the legacy systems where data has never actually been used properly. Kind of goes into Hadoop as well. Like a lot of the promise of Hadoop was using data more effectively. But what happened was the data wasn't used in a timely manner, and it wasn't used where the value is. And we talk about the half-life of data. So as soon as you have data, it's important. It's at its most valuable. And every moment from then, it becomes less valuable. So using data when it's at its current or real time is the most important thing to changing how you become a data-driven business. And the other thing that is important around data, and speed is especially, we talk about transactions a second, but the other part about it is context. Now, if you think about data in a simple way, you could say, well, a piece of data is important. Say, for example, we're talking about a car, an Uber car, and you say, I know where a car is at a certain time in a certain time. So that's one piece of data, and at the time you know that, that's important. But what's more important is the context that piece of data lives in. So what you need to do as application developers and architecture developers, we need to be able to say, well, how can I put that piece of data in context? So if I can look at the last 1 minute of data or the last 1 minute of locations for that car, now I can start to think about that differently. Now I have a vector, right? Now I can see where the car is headed. Now I know by how different the locations, how fast the car is moving. Now I can think about, is the car speeding up? Is the car slowing down? So all these small pieces of the data put in context now start to give us insights, right? So now we start to turn it into information. Now we can think about, well, is there a destination? How long it will take at my current speed? All that has to come into play because the data on its own isn't actually as useful without the context. Sorry, I dove into a little rabbit hole there, so apologies. Phil, any thoughts before we move on?
Yeah, well, I think there's one other point to that, and that is having a single data store that can be used by developers for these kind of operational apps. The idea that the data is valuable as soon as it's collected, but being able to also go back and look at, over the last 3 months or 4 months, to be able to do queries around what is the delay or what is the average time that it takes a car to get from this city to that city or this location to that. So all of those analytics, I'd like to be able to do all those without picking the data up and having to move it again. And that's what technologies like Cassandra let me do. They let the operational analytics happen, but they also let the longer term, they also support the longer term analytics all with one data store without moving.
Yeah, that's a really great point, Phil. And I think when we think about the huge deluge of data that's coming now, there's two things that are going to be really, really important. One is the data modeling. And when I say modeling, I mean more around algorithmic modeling. So if you think about automation and autonomous cars, for example, to build an autonomous car, you need huge amounts of data. And that's mainly historical data. And that's usually raw data, it's sensor data, it's learning models, in terms of how we create the brain of the car. And that requires massive amounts of data. But then there's the real-time aspect. So when the car has the brain, right, it understands the model and it starts to drive, then it's what happens from the AI point of view. It's learning all the time from its environment. It understands signposts, it understands obstructions in the road, and that data has to be processed as fast, like in sub-millisecond. But then that also needs to feed back into the model, right? So that the car continuously goes on this learning journey. And this is not going to be just from a car point of view. It'll be people and medicine and automotive and all these different things. So it's a great point, Phil, that the data that comes in is not just used for the real time. It needs to be needs to be used for other cases that need that historical hot data as well. So we're kind of coming to the end here. So you've heard from myself at DataStax. Phil, is there anything else you'd like to add before we move on?
Well, there was a footer on one of the early slides that said, there's no one technology that does it all. I mean, and I think that's really important that you take away, that we're not suggesting that there is one technology that answers every problem for you. But you also don't want one piece of every technology in the world. And so the question here is how many of your use cases and how much of your data footprint demand can be solved with the fewest number of technologies. And I think if the only thing you have in your toolbox right now are relational databases, I think it's really time to think about, how you could actually simplify your life by slightly expanding the number of technologies that you're using to handle a much broader use of use cases and a bunch of new applications and use cases that you can't actually even do today.
Mm-hmm. Absolutely. So you can see here there's plenty of places to learn more. You can connect with DataStax or Dell Technology Sales Representative. There's lots of information. There's a white paper going to accompany this webinar as well. So there's plenty of resources that we could share. And there's obviously taken a test drive on Dell Technologies, the Customer Solution Center there. Kelly, did you want to take this? Oh, sorry. Is there any questions, by the way? Please, you can put some questions in the chat, and we'd be happy to address them.
Okay. Well, I want to thank Patrick and Phil. Thanks so much. Before we begin with today's Q&A, please direct your attention to our webinar survey. It's available on the right of the presentation window. If you close the survey, you can reopen the widget by clicking the icon along the bottom of your screen. We thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. And now on to the Q&A portion of our event. As a reminder, to participate, simply type your question into the text box located to the right of the presentation window, or just click the Q&A icon at the bottom of your screen. If we're not able to answer all submitted questions during today's webinar, we'll be sure to share them with our speakers who can reply to you offline. Okay, we've got a few questions that have come in. Here we go. How does DataStax work with or in a hybrid cloud environment? Okay,
great question. So because Cassandra was built by Facebook, I don't know if many of you wouldn't have known that, but and what it was built for, one of the reasons it was built was for high availability. And what that did was it allowed it to replicate in real time to multiple data centers. So, when you think about an East Coast and a West Coast for people in the U.S., you could have a database that spans the entire U.S., but replicated itself in real time. There's no extra processes or services needed. It would just automatically do it. And that allowed then for the high availability in terms of if one of those data centers was to go down, you would always have a full replica up all the time. It wouldn't interrupt any of the processing for the applications. Now, in the world that we live in, hybrid cloud and multi-cloud is a big thing. And in the same way, you can take a database in Cassandra and have one data center living on-premise and another data center living in the cloud. In fact, we have, for maybe a company like FedEx or similar, they've got, maybe 5 or 7 or maybe even 9 data centers around the world where important reference or metadata is actually replicated in real time. I worked for a time with UBS, and we worked on one of their global bank platforms. And what we did was we had data within Europe where we processed a lot of the information, but that was then replicated in real time to both the US region and the APAC region. So Cassandra was made to do this by default. It's not something that's ever been added. It just, because of the data center replication that's been built in, hybrid cloud and multi-cloud is incredibly a useful tool.
Okay, here's another question. I saw the Capital One example. Are there others you can share?
Yes, certainly. There's lots of examples. I'll give you one that's really interesting to us because we're doing our sales kickoff next week, and we have speakers by the Home Depot. And if you visited the Home Depot or if you used the application and the services that they provide, you'll know that it's a pretty classy service. One of the things they did during COVID is the curbside pickup. And this was where you could order online and you could drive into one of their parking lots and use the app to say I'm here, and they'd come out with your goods straight to the boot of your car, and off you go. That was developed from concept to production in less than 30 days. It was like we talked to the team there. They pretty much had it done in about a week, but it had to go through testing and all the different integrations that they wanted to do. But it was done within a month. That allowed them to increase sales, quarterly digital sales, by 100%. That one application. And that changed how, Home Depot have always been data driven. They've always, been, innovative in the way they think about their enterprise. But that, one example shows how important having data in the right place is. So yes, they made an application or a service that increased, digital sales 100%, but 3-4 years ago, when they decided to go NoSQL and Cassandra and DataStax and the distributed route, that's when the real work was done to enable the quick turnaround in applications driven by the data, driven by interactions, by customers. So that's a really interesting story that I think would resonate because people probably use that quite a lot.
Got it. Okay. Any great insights or tips in migrating to Cassandra NoSQL?
One of the things Cassandra is a very simple database to use. We have a Cassandra as a service. We have Cassandra on Kubernetes and Docker. These things are very simple to spin up and just test drive. What I would say, and I can see there's another question there around migrating to NoSQL or Cassandra distributed data models. One thing that you would consider is that when you're coming from a relational or mainframe type of data model, really, if that's what you've known for a long time, there is some education that you need to go through to create a data model that scales and is distributed. Really, that's around what we call a query-driven data model. So you create your data model like you're going to query your data. So if you're coming from a relational world, it's very much like creating views. So people create views so they have one table or view that they hit instead of going to multiple tables where you need to do complex queries and joins. Similar to NoSQL and Cassandra, you create a table where you're going to select using an ID that actually is going to give you a lot of information back. And this goes hand in hand with API development as well. So if you think about, if you're creating an API service to expose your data, what you're usually doing is you're creating API signatures or parameters that allow the user to be able to see what you're going to expose. For example, give me all the customer interactions from this customer ID from this date to this date. So what you're using the parameters that you're being given from that API to be able to query the database in a query-driven way. So that's the one thing I would say. If you're coming from a relational data modeling perspective, just give yourself that little bit of space and time to check how distributed data models are created.
Okay.
But from a developer side, if you look at CQL, if you have any experience with PL SQL or T SQL or K SQL or any of these others, you're going to find the query language to be very, very familiar. And this idea of, it's probably going to look more like a denormalized database to you, but so from a developer standpoint, I think there's a lot of similarities, and it's not as big of a jump as you might think at first thought.
Okay, good. We have one question left. Are there any gotchas to migrating to a distributed data model or to NoSQL?
Yeah, so that's what I was alluding to with the relational to data modeling, a relational to distributed data model. It's just something that you need to keep in mind at all times. It's just a different way of thinking about data, really. It's about looking at how we're going to query data. The thing about distributed data models is that they need to be set up in a way that's somewhat not predictable per se, but you have to have an idea of how data is going to be used. And again, if you think about microservices as being the way most people now are consuming, or by APIs as the way most people are consuming data, then it really fits really well with a query-driven model.
Okay. A question just came in. Just wondering how you feel about Red Hat ending the support cycle for CentOS or Elasticsearch changing to a non-free software license.
Well, I'll give you the Elasticsearch one first. I think it's difficult for a software vendor to spend a huge amount of time investing in the community, investing in tools, open source tools, integrations with other technologies, and creating a product, and then seeing if pretty much, I'm not going to say stolen, I don't want to pretend to say stolen in this kind of format, but all that technology and great community work taken to just put in a marketplace or a platform and nothing given back. So we, as a contributor to open source Cassandra, we work heavily with people like Apple and Netflix and Spotify on evolving the Cassandra database and the Cassandra community. And that is not just on the product, but the tooling, the support, the blogs, the webinars, all that information. And then you have other companies, and I'll just say like AWS, for example, that will take all that goodness that's been created and then just offer it as a tool where the only people making money or benefiting from it is AWS. So there's no contribution back to the community. There's no contribution to any of the tools. So that's really difficult. And so it's kind of hard to say that Elasticsearch are wrong for changing their license. But then if you feel that Elasticsearch may end up, being an unsuccessful company because I think some of their IP is being stolen, then hard to know. I'm not sure about the Red Hat. Maybe Phil, you have a better idea.
No, that's not an area that I have any deep knowledge of. No.
But I think open source is a force for good in the tech world. Open source has created some of the best technology out there. You think about like just Unix, for example, but all the Apache Foundation projects that we work on, like so much of the technology that we work with, and not just in Cassandra, but even the tools. So even the tools that we build, we use a huge amount of open source technology in those. So open source is here to stay. It's one of the best things about technology and one of the best things about working in this industry.
Okay, before we wrap up, I just want to ask our speakers if there are one or two things you'd like our attendees to remember from this webinar, what would they be?
Well, I'm going to say that. Oh, go ahead, Patrick.
Sorry, go on, Phil.
So I was just going to say that this technology is really easy to experiment with. And so, you can't walk away from a webinar like this and make any hard decisions. You're going to have to do some experimentation. And even if you're not sure where this technology might be applicable to you today, I think it's worth spinning up some containers and playing around with the technology and learning a little bit about it. Try moving some data from a relational database into a Cassandra database. Try running some queries against it, and see if that doesn't kickstart your creative juices a little bit about some things that you could do better than you're doing today.
Yeah, great point, Phil. For me, I would just say I think it has to be about more than just the database, right? And this is where the collaboration with Dell and Intel and DataStax come in. If it was just about a database, putting data in and out, then any database will fit your needs, right? But if you're thinking about high throughput, scalability, if you're thinking about high availability in terms of 100% available, if you're thinking about portability and ease and flexibility of use, and if you're thinking about things like AI and how to make your company more data-driven and putting data at the center of everything you do, then I think at least you need to look at NoSQL technologies and Cassandra and DataStax in particular.
Okay, terrific. Well, that's all the time we have today for questions. I want to thank Patrick and Phil. Information Week greatly appreciates your time and expertise on today's topic. And I want to thank our sponsor, Dell, as well as to everyone in the audience. We appreciate your attention and your participation. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may not have been able to listen to the event. This webinar is copyright by Informa. The presentation materials are owned by or copyrighted by Information Week and Dell, and our individual speakers are solely responsible for their content and their opinions. On behalf of our guests, Dell, I'm Peggy Bresnick-Kemler. Thanks for your time, and have a great day.